This is our introduction to AP Physics class video, and before we start AP Physics, I want to show you which type of math you need to know. So this is just introduction to the math, and then the second video I think will be all physics related, but this one is mostly math. So we will start with the unit circle. And before that, we will look at what right triangle is and how the relationship between different angles work. So if I have a right triangle, and some people may have taken enough trigonometry or geometry to understand this, but sometimes I get students who have never seen this before. So if this is my angle, then so I'm gonna use this as letter theta, and the angles of the triangle are gonna be A, B, and C. And so if I say trigonometric functions, right? So when they decided, so with the triangle, with the angle, you have an opposite side of the angle, you have adjacent side to the angle, and you have hypotenuse. So when they decided they're gonna talk about the proportions, so it's all about the proportions of the angles, of the sides of an angle. So when they decided to talk about the proportion, they want to say, for let's say if angle is 30 degrees, then this side over this side is always going to be the same no matter how big the triangle is. So I can have a smaller triangle as long as this angle is 30 and this is the right triangle. The proportion of this side to that side is always the same. So it doesn't matter how I stretch or make that triangle smaller, the proportion stays the same. So instead of calling it always, so there's going to be tangent. We're going to look at tangent, theta, we're going to look at sine theta, and we're going to look at the cosine theta. And for tangent, they said, okay, it's going to be the opposite over adjacent for that angle, the opposite side of that angle and the adjacent side. And I'm going to call them like this: A, B, and C. So this is A, this is B, and this is C. So for tangent, it's going to be the opposite over adjacent. So it's A over B proportion. So they didn't want to call it every single time A over B over A over B. So they gave it a name. They said it's going to be tangent. So tangent means it's A over B. It's an opposite over adjacent. And then for sine, it's going to be the opposite over hypotenuse. So instead of calling it the opposite over hypotenuse every single time, they just decided to call it sine. And for cosine, they said it's going to be adjacent over hypotenuse. So instead of calling it every single time adjacent over hypotenuse, they gave it the name cosine. And there are some specific angles that you need to know. They're going to be 30-degree angle, 45-degree angle, and 60-degree angle, and everything else is related to them. We also are going to call this is a unit circle. Unit means the length of the radius is 1. So if this is the center, then this point in the coordinate plane, if this is your y and this one is your x, the points are going to be 1, 0, because the length of the radius is 1. This one is going to be 0, 1. This one is going to be -1, 0. And this is going to be 0, -1. And then they looked at this specific angle. So this one is going to be 30 degrees. And then this one is going to be 45 degrees. So there is a triangle related to 45 degrees. And I'm going to call this one is 60 degrees. and this another right triangle. So for every single one of them, what you need to know here is, instead of calling this horizontal line x, I'm gonna call it cosine, and instead of calling this vertical line y, I'm gonna call it sine. So for every single point for each specific angle, there are coordinates, and they're only, if you already especially taken the class where you had to memorize right triangle, there are only certain numbers that you can have for sine and cosine. So for sine and cosine, you only can have these numbers: 1/2 square root of 2/2 and square root of 3/2. And for tangent, you only can have 1 over square root of 3, 1, and square root of 3. So for the green triangle, if you look at the green triangle for 30 degrees, so for the green triangle, I see that my x is the longest of all 3 triangles, and my y is the shortest of all 3 triangles. So I know from these 3 numbers, my x is the longest, which is the square root of 3/2, and my y is the shortest, which is 1/2. Now if I look at my purple triangle, right triangle, and at the angle of 45 degrees, my x and my y are the same, and because it's 45 degrees, so I have the square root of 2/2 and square root of 2/2 because it's the medium size between the other 2 triangles. And then for my largest triangle, for the y is the largest, right, not the x. X is the smallest here from 3 triangles, and y is the largest. So for this one, I have x is the smallest, which is 1/2, and y is the longest, which is the square root of 3/2. So this is for these triangles. But then if you look on the other side of the 60 degrees, this will give me exactly the same triangle. So this one is the shortest, x and y is the longest, but in this coordinate I have both y and x negative, so I have negative 1/2 and negative square root of 3/2. And then for the purple, I will have negative square root of 2/2 and negative square root of 2/2, both negatives. And for the green part, I will have the longest x and the shortest y, so I'm going to have negative square root of 3/2 and negative 1/2 for y. And then the same I can do for the rest of them. So if I look at this triangle right here, I see my x is the longest and my y is the shortest. X is the longest positive, so that is the square root of 3/2, and y is the shortest of 3 triangles in this quadrant, right? So in this quadrant, y is the shortest, and that is negative 1/2, because that's the negative for y coordinate, for y quadrant in this quadrant. And this is your y, this is your cosine, and this is your sine, because we decided this is going to be cosine and this is going to be sine. So now if I look at this triangle right here, that gives me the longest y, the shortest x, and both negative. So that is negative 1/2 and negative square root of 3/2. If I look at this triangle, then I have the shortest y, the longest x. So negative square root of 3, because x is negative, over here, negative square root of 3 over 2, and 1/2 positive. So this is again my cosine, and this is my sine for that angle. But now I need to know what those angles are that I'm talking about. So I have 30 degrees, plus 30 gives me 60 degrees, plus 30 gives me 90 degrees, plus 30 gives me 120 degrees, plus 30 gives me 150 degrees, plus 30 gives me 180 degrees, plus 30 gives me 110 degrees, plus 30 gives me 240 degrees, plus 30 gives me 270 degrees, plus 30 is 300 degrees, 330 degrees, and 360 degrees. And then I have 45 degrees, plus 45 gives me 90, plus 45 gives me 135 degrees, plus 45 gives me 180, plus 45 gives me 225 degrees, plus 45 gives me 270, and plus 45 gives me 315 degrees. And then I'm gonna do them in radians. So in radians, pi over 3 is pi over 6. In radians, pi over 6 is 30 degrees, because pi is 180. So 180 divided by 6 gives me 30. So now I'm going to rewrite them in radians. So this is pi over 6. This one is 2 pi over 6, which is pi over 3. This is 3 pi over 6, which is pi over 2. This is 4 pi over 6, 2 pi over 3. This is 5 pi over 6, just 5 pi over 6. This is 6 pi over 6, which is just pi. This is 7 pi over 6. This is 8 pi over 6, which is 4 pi over 3. This is 9 pi over 6, which is 3 pi over 2. This is 10 pi over 6, 5 pi over 3. And this is 11 pi over 6. And 12 pi over 6, which is 2 pi. And then for tangent is, so if I look at this part, this is your tangent part. So for this angle, your tangent part is longer. And for that angle, the tangent part is going to be the longest of all of them. So if I look at the tangents, you see the numbers that I have is 1 over square root of 3. You will see that square root of 3 over 3. But I like to write it this way, from the smallest to the largest. You see that the first one is the smallest, the medium, and the largest. So for this one, your tangent is the smallest of all 3, right? So from all 3 triangles, this is the smallest. So tangent of 30 degrees is 1 over square root of 3. And then for this triangle, this is the tangent, and it's the medium one. So tangent of 45 degrees is 1. And then for the last one is going to be the longest of all, and that is going to be tangent of 60. Tangent of 60 is square root of 3. And I can look at the different parts. So let's say I'm going to look at this one. I'm going to make it prolonged that way, and this is going to be the length of it. So the tangent of, and I need to know what this angle is. So this is 270, and 30 less gives me 240 is equal to, and this is the largest one. And because this is negative part, and the negative part gives me the positive, so I have a negative x and a negative y, so my answer is positive. And the tangent of 240 degrees is going to be the square root of 3 positive. I will choose the hardest questions for you to do for practice, but some of the easier ones I want you to try at home yourself with our practice questions. So I'm just going to jump to number 8 right here. So they say that you are on a parade looking up at the balloon floating directly above the street. You are 60 feet from the point on the street directly beneath the balloon. So you are 60 feet away from the balloon. And to see the top of the balloon, you look up at an angle of 53 degrees. So the angle right here is 53 degrees. So that's the top. And to see the bottom of the balloon, so the bottom of the balloon gives you 29 degrees. So that part is 29 degrees. And they want you to estimate the height of the balloon. And because I have, I'm looking at the angle, the sides that are adjacent and opposite to the triangle and my right triangle part. So I need to, the sides, I need to look at, so I'm going to look at the yellow one first. So I'm going to call this part A. So the short part right here is A. And I'm going to say that the tangent of 29 is equal to A, the opposite, over adjacent, over 60. And for the green triangle, for this part, I'm going to say that the tangent of 53 is equal to h, the height of the balloon, or the balloon, plus A over 60. Then I'm going to times both sides of these equations by 60. So I get from one equation, A is equal to 60 tangent 29, and h plus A is equal to 60 tangent 53. And then I'm going to plug in my A into the equation. So I'm going to plug in this part instead of A because A is equal to that. So what I have is h plus 60 tangent 29 is equal to 60 tangent 53. So h is equal to, I'm going to subtract and take 60 out. So I'm going to take 60 out, and I have tangent of 53 minus degrees, tangent of 29 degrees. And that gives me 46.4 feet. Here's another example. A boat is cruising along the coast. A point is sighted at an angle of 31 degrees. After continuing 4.8 miles, another sighting is taken and the point is found to be 55 degrees from the course. How close will the boat come to the point? And when they say how close, they mean to find this distance, the closest point to the point, the closest distance to the point. So I'm going to call it y. And I'm going to look at first triangle is the green one. And then I'm going to look at the triangle that is the yellow one. So let's look at the green triangle, right triangle, because it's a right triangle, right? So at the green one, I have, in this case, you can use tangent, but to do easier the math-wise, I'm going to do it with cotangent. So cotangent is the reciprocal of tangent. So if you have tangent is equal to the opposite over adjacent side of the angle, then cotangent of an angle is equal to adjacent over the opposite. So it's just the reciprocal of it. In your calculators, you will not see cotangent. So what you have to do, so if you have to do a cotangent of 31, you need to type 1 over tangent 31 in your calculator. So back to our cotangent. So for cotangent of 31, I have the adjacent, which is 4.8 plus x. The rest of the path is x. that they show you. So this is x and this is 4.8, and divide by y. And for the yellow, I have cotangent of 55 is equal to x over y. So I have a system of equations, and one of my students in the past came to visit my classes after he already graduated from high school and he went to university. And one of the advice that he gave to the students in the classroom for AP Physics, he said, you must know how to solve system of equations. So a lot of problems solving in AP Physics is going to be involving system of equations. So I'm going to solve this for y, for x. X is equal to y cotangent of 55 degrees. And then I'm going to take this and plug it in instead of x. But at first I'm going to multiply both sides by y in the green equation. So I have y cotangent 31 degrees is equal to 4.8 plus, and instead of x, I have y cotangent of 55 degrees. Then I'm going to subtract y cotangent 55 from both sides. So I will have y, and I'm going to factor out y. So I have cotangent of 31 degrees minus cotangent of 55 degrees is equal to 4.8. And then if I divide both sides by the parenthesis, I have y is equal to 4.8 divided by cotangent, but I know I don't have this in my calculator, so I'm going to do 1 over tangent 31 minus 1 over tangent 55 degrees, because that's how I have to plug in my calculators. And then after you do these questions, always make sure that you plug in the numbers before. Don't do all of them at once in your calculators. I know you want to type the whole problem into the calculator and do your calculations, but this is where you usually make mistakes. So what I'm going to do, I'm going to take 1 divided by tangent of 31, and I'm going to write 1/66 minus 1 divided by tangent 55, and that will give me 0.7. And then only after that, I'm going to plug into my calculator and say it's 4.8 divided by 0.96, and I get my answer as 5 miles. I think that's numbers were given in miles. So that will give me an answer for number 9. Here's one more question that we're gonna do before I finish this video, and then the next video is gonna have the law of sine and cosine in it. So they have that you have a family room that has a sliding glass door with a southern exposure. You want to buy an awning for the door that will be just long enough to keep the sun out when it is at the highest point in the sky. The angle of elevation of the sun at this point is 70 degrees, so you see it in the picture. And the height of the door is 8 feet. So they give you the height of the door. About how far should you overhead the extend? So if I look at my triangle right here, then I see that this angle right here, the little one, that is 20 degrees. And I'm gonna call this angle theta again. And I have the opposite of this angle and adjacent, so I'm gonna use tangent. So I'm gonna say tangent of 20 degrees is equal to the opposite, which is x, over adjacent, which is 8. So x is gonna be equal to 8 tangent 20, which is 2.9 feet, because all the numbers were given in feet.